Hello students, welcome back to my channel. Now I will start electrolysis rest part, electrolysis of copper sulfate solution. First, using platinum anode and copper or platinum cathode. This means platinum anode that is inert and copper or platinum cathode that may be inert or active. Okay. In second figure, that is electrolysis using copper electrode, means using active electrodes. I told you in the last class, both active means, suppose active anode means any ion may migrate to the anode but neither will be discharged. However, the anode itself will disintegrate into ions. But in cathode, it may be active or inert, but the ion which is lower in electrochemical series will always be discharged at the cathode. But in case of anode, if it is active, because it is connected to positive source, if it is active, then it itself will disintegrate into ions. So, using platinum or copper or platinum cathode, first electrolytic dissociation, because I am using here dissociation because copper sulfate. Copper sulfate means that is you are the metal and non-metal, so ionic compound. So here you can use the word dissociation or you can use electrolytic reaction. So that is copper sulfate, Cu2 plus SO4 2 minus, then H2O, H plus OH minus. So first you see both, first then we will start cathode reaction. So then I can say cathode reaction. So to cathode, both Cu2 plus and H plus ion will migrate to cathode, but out of them Cu2 plus ion will be discharged because it is lower in electrochemical series. So at cathode, Cu2 plus 2E minus give rise to copper. So what will be deposited at the cathode? Pink or reddish brown copper metal will be deposited at the cathode. Okay, then anode reaction. To anode, both SO4 2 minus ion and OH minus ion will be move or migrate. So out of which OH minus ion will be discharged, because OH minus is lower in electrochemical series. OH minus ion minus E minus, so give rise to OH. Then 4OH give rise to 2H2O plus O2. So oxygen gas will be evolved at the anode. Okay, complete. But if we use copper electrode, means I told you, always think over whether the anode is active or inert, because anode is active here anode was inert. So anode active means cathode reaction will be same. Cathode reaction, I am writing only cathode reaction. In both case cathode reaction will be same. In cathode, what will be deposited? Copper metal will be deposited. So cathode reaction is same in both case. So only I will write anode reaction. Okay, to anode, the ions will be migrated to anode, OH minus or SO4 2 minus. Out of them neither will be discharged because anode is active in nature. So anode itself will disintegrate into ions. Anode Cu minus 2E minus give rise to CO2 plus. So now one important question arises in both cases. Here size of the anode will gradually decrease. One important question arises in this case, the blue color of the copper sulfate solution will fade because when the ions will migrate to the cathode, then gradually its blue color will fade. But in this case, the blue color of copper sulfate solution will not fade because how much ion will migrate to cathode, the same ion will be replaced by the disintegration of anode. So in this case, blue color will not fade. Okay. Then this portion completed. Next one, electroplating. Electroplating, the process of deposition of a superior metal over a inferior metal to make it decorative and long lasting is called electroplating. ओके, कुछ मेटल का ऊपर हम एक दूसरा मेटल एक माने ये दे देंगे, कोटिंग दे देंगे ताकि ये लॉन्ग लास्टिंग होगा और थोड़ा डेकोरेटिव रहेगा. ओके, इन और सिलेबस इलेक्ट्रोप्लेटिंग ऑफ कॉपर सल्फेट ना nickel by using nickel sulfate solution and electroplating of silver by using sodium argentocyanide solution. Sodium argentocyanide is a complex salt. Okay, first nickel sulfate, using nickel sulfate solution we can say electrolysis of electroplating of nickel. Okay, same thing and not pure nickel. This means this is active and cathode. Article to be electroplated. जो आर्टिकल का ऊपर हम इलेक्ट्रोप्लेटिंग करेंगे. ओके, सो हियर इलेक्ट्रोलाइट क्या होता है? NiSO4 प्लस H2O. ओके, फर्स्ट इलेक्ट्रोलाइटिक रिएक्शन. NiSO4, Na2 plus SO4 2 minus. Okay, then H2O, H plus O minus. Okay, OH minus. Sorry. अच्छा. Now I can say cathode reaction. Ni2 plus and H plus will migrate to cathode, but out of them Ni2 plus will be discharged because it is lower in electrochemical series. So Ni2 plus 2E minus. Okay, pure white nickel metal will be deposited at the cathode. So cathode completed, then anode reaction. To anode, the ions SO4 2 minus and OH minus ion will be migrated, but out of them neither will be discharged because anode nickel is active in nature because it is metallic electrode. So nickel itself will be disintegrated into ions Ni minus 2E minus Ni2 plus. Okay, so the size of the anode will gradually decrease. Okay, this is the electrolysis of nickel by electroplating of nickel by using nickel sulfate solution. Then electroplating of silver. by using sodium argentocyanide NaAgCN2 solution. Okay, I can say you, so that is pure Ag, pure silver. This is article, suppose you can also use like a spoon. This is article to be electroplated. Okay, so that is pure Ag, that is anode and that is cathode. Cathode means what should be remain in the cathode? Article to be electroplated. Article to be electroplated. Okay, so here sodium argentocyanide solution, Na electrolytic reaction, NaAgCN2, Na plus Ag plus Ag plus 2Cn minus. Okay, one thing I just distinguish you one thing, just you visualize clearly. Instead of sodium argentocyanide, I can also use AgNO3, very important. So if AgNO3 is to be, we are to be used instead of sodium argentocyanide, then it will give rise to Ag plus NO3 minus. Okay, so if you use AgNO3, then you can also use the method of electroplating easily. But instead of AgNO3, sodium argentocyanide is used. Why? Because if AgNO3 will be used as electrolyte, then the coating becomes very fast and uneven. Okay, that's why to make the coating smooth, uniform and even in nature, sodium argentocyanide is used instead of AgNO3 silver nitrate. Okay, then one question arises, how if sodium argentocyanide is used, and still we can say how the coating will be uniform. The coating will be uniform if we use slow voltage or low voltage current for long time, then the coating will be uniform. We are not using AgNO3 because AgNO3 is rejected. It will not give smooth uniform coating. We are using sodium argentocyanide. After using sodium argentocyanide, still question arises, how can we get uniform and smooth coating? Because if you use slow current, low voltage current for a long time, then the coating will be uniform. Okay, then I can say cathode reaction. To cathode, both the cathode Na plus Ag plus and Na plus Ag plus will be migrated. Also H2O. I forget H plus OH minus. Okay, so Ag plus Na plus H plus will be migrated, out of which Ag plus will be discharged. So Ag plus plus E minus give rise to Ag. Pure white silver metal will be deposited at the cathode. Okay, हम जो पूजा वगैरह करते हैं उसी का ऊपर जो चामच का ऊपर जो होता है कोटिंग, हम बोलते हैं वो चांदी का चामच है, एक्चुअली वो सिल्वर कोटिंग दिया जाता है बाय इलेक्ट्रोलिसिस मेथड. एनीवे, सो व्हाट अबाउट एनोड? टू एनोड Cn minus ion, then OH minus ion will be migrated, but neither will be discharged because anode is active in nature. So anode itself will disintegrate into ion. Ag minus E minus give rise to Ag. The size of anode will gradually decrease. Okay, so this is the electroplating of silver. Only one portion is remained, that is electro-refining. Electro-refining इसका मतलब होता है कोई चीज को हम रिफाइनिंग करेंगे. कैसे? The electro-refining is a process by which metals containing impurities are purified electrolytically. Electro-refining is a process by which metals containing impurities can be removed electrolytically. इम्प्योरिटीज मतलब तुम मत सोचो कोई माने कीचड़ वगैरह को मिट्टी कीचड़ ये नहीं। इम्प्योरिटीज मतलब एक मेटल के साथ दूसरे मेटल मिलके रहता है। ओके, सो हम उससे रिफाइनिंग करेंगे। सपोज ये दिस इज कैथोड, दैट इज इम्प्योर कॉपर। इम्प्योर कॉपर मीन्स इसमें इसके साथ कॉपर, जिंक, एल्युमिनियम, आयरन ऐसे सब मिलकर रहा है। अच्छा, ये हो गया ये एनोड। दिस इज नॉट कैथोड, दिस इज एनोड। ओके, सो दिस वन कैथोड। ओके, कैथोड इज मेड अप ऑफ प्योर कॉपर। Cathode is pure copper. So we should use the electrolyte copper sulfate solution. Okay. So in case of copper sulfate solution, I just connect it to positive negative. So this you see one thing. Copper sulfate solution likewise dissociate copper sulfate solution, electrolytic dissociation Cu2 plus SO4 2 minus and H2O, H plus and OH minus. So I can say both Cu2 plus and H plus will migrate to cathode, out of which Cu2 plus will be discharged. So at cathode में what will be the reaction at the cathode? Cu2 plus 2E minus give rise to copper. Weak or reddish bound copper metal will be deposited at the cathode. But what about anode? To anode you see OH minus SO4 2 minus both will migrate, but neither will be discharged because anode is active in nature. So you just watch here. Active means out of all impurities, which one is more active, that will be discharged. So we should choose the electro-refining method in such a manner that the metal which is more active, the short solution of that metal is taken as electrolyte. So out of which copper is more active. So ये चार में से सबसे ज़्यादा एक्टिव जो होता है ये वो पहले निकल जाएगा, डिसइंटीग्रेट हो जाएगा. So at anode reaction, at anode what will happen? Both माने OH minus SO4 2 minus will migrate to anode, but neither will be discharged. But anode itself, as copper is active, more active than others, then it will disintegrate Cu2 plus. The size of anode will gradually decrease, and the impurities like other impurities, zinc, aluminum, iron, that will fall down at the anode as anode mode. What is this? This is anode mode. So my dear students, the portion of electrolysis which is in syllabus is completed. Okay, so in coming class we will take any chapter in other subject. So I may start, I am thinking I will start physics or the language subject like history. Okay, so I need your comment. Please comment me as soon as possible. According to your views I will proceed further. Thank you.